Hello, so welcome to the data frame section of our course. So to define a data frame, it is a two-dimensional labeled structure, this time specifically with columns of potentially different types. So this data frame is similar to a spreadsheet if you're familiar with Microsoft Excel, or if you're familiar also with SQL table. Data frames are the most commonly used Pandas objects. We will extensively use data frames throughout the duration of our electives. So to demonstrate to you, let us construct a data frame. So we will construct directly for as an example from a data frame. So we define df is equivalent to pd dot data frame. So that's capital D and capital F. So we'll create a random number 5 by 5 matrix. So for example, random dot rand. So remember your function. So random dot rand will create a 5 by 5 matrix of random number. So the second argument will be the row indices. So let us denote this one by R1. So R2, R3, R4, and R5. So the next parameter for the data frame will be the column name or column indices. So C1, C2, C3, C4, C5. Then I think we have 5 only. So let's take a look at the data frame. So Alt Enter. So this will be the structure of a data frame. So from previous lecture, remember, we have only row indices when we are using the creating or using a series. So this one. But now we have column indices when we are creating a data frame. So that's the main difference. So series only has one specific indices, specifically the row. The data frame has column indices. And this looks like a typical spreadsheet. This looks like a tabular data. We have rows and columns. So think of this one as a spreadsheet. So let me erase this one. So to continue, so how about we create a data frame from a dictionary? So I will paste the value from previous lecture so that to save typing time. So Control V. So we have area of dictionary. So we got a key value pairing of California, Texas, New York, Florida, Illinois. Then we can assign a variable, and out of that variable, we created a Panda series of the specific dictionary. So let me execute this one. So this one is a series. So remember, this has no column indices, but only row indices. So the indices here is California, Texas, New York, Florida, Illinois. And to confirm this one is a series, so you type the type function and you type the variable. So this one is Panda series. So another one, if we create another set of dictionary, then we will convert this one into series. So for example, let me paste this value. Population dictionary, we assign it to population variable. Then we denote population so that we can see the structure. So this is also a series. Okay, so type, for example, this one is population. So Alt Enter. So this is a series also. And for the last one, so we will create a code dictionary for the specific US state. So I'll paste the code. So California, CA, Texas, TX, New York, NY. I'm not familiar with US state codes, but assuming this is correct. So again, I'll execute this one. So California, CA, Texas, TX. So again, this one is a Pandas series. So out of this 3 Pandas series, we will create a data frame out of the dictionary. So for example, states is equivalent to pd.dataframe. So again, capital D and F. So out of this one, we will create a data frame. So let's say we have the area column, then we plug in the area values. So we have the population column, the population values. These are series that we defined earlier. Then we have the code, and we have the code values. So states. So this is the structure of a data frame coming from dictionaries converted to series. Then the series are converted to data frames. So this one, we have here column indices of area, population code, row indices of California to Illinois. So this is the values. So these are the data that we plugged in. We can also use to check that it is indeed a data frame. So again, you type then the value of the variable states. So this is indeed a Pandas data frame. Like a series object, a data frame has also an index attribute, and it gives access to the index labels. For example, we have the variable states, then we define the index method. So we have this specific index, California, Texas, New York, Florida, Illinois. We have also the column attribute. So states that columns, so with an S. So Alt Enter. We have index of area, population, and code. So these are the code to check for the index and column names. So you can think of a data frame as a generalization of a two-dimensional NumPy array where both rows and columns have indices for accessing data. If you want to ask for the area attribute, and it will return a series object containing the areas. So let me demonstrate. If you state this one, so for example, your code is states, then if you're familiar again with the square bracket notation, so specifically you're asking here to access the values for the area. So I will execute this one, Alt Enter. So indeed, these are the value for area. So 423967 to 14995. So it states that you can access specific parts of the data frame by denoting its indices, either rows or columns. So for example, of constructing for data frames, Pandas data frames can also be constructed in various ways. So you can construct data frames from different objects. So let me delete this one. So from a single series object. So remember that a data frame is a collection of series objects. Single column data frame can be built using a single series object. So let me demonstrate that to you. pd.dataframe. So we have the population. Then also we have the columns. Then we denote this one as, for example, is a population. So from a single series, remember this is a series, so we can create a data frame. So let me execute this one. So this will be the result. So again, the difference here is it has column indices or column names. So also, so you see this one earlier, we can also create a data frame from a list of dictionaries. Note that any list of dictionaries can be a basis of a data frame. So let me demonstrate again. Data is equivalent. Let's pipe this one into list. So key value pairings. So A, I, so B. So let's say we square the value of I. So remember, so double star or double asterisk is a square. Then we will use a for loop here. So this is list comprehension. So for I in range, so from 0 to 3. So I will execute this one. So Alt enter. Then let's check the data. So as you can see here, so we can create a list of dictionary can be the basis of a data frame. So let's pipe this one down into a data frame. So our parameter will be the data, and look at the results. Sorry about that. So still, so we have created the row indices of 0, 1, 2, and column indices of A and B with 0, 0, 1, 1, and 2, 4 as their values. So we can also, from a dictionary of a series object, so I think you already seen this one. You already seen this one. So if I execute this one again, so PD data frame. So again, we have population. So let me repeat that. So we have population. Then we have area. So this is similar to the above codes. So if we execute this one, so we have the same structure of the data frame. Also, from a two-dimensional NumPy array, you can generate a data frame. Given a two-dimensional array of data, we can also create a data frame as stated. Let us use the columns and index property here. So for example, I think you already seen this one, but for the benefit of instruction, so I will repeat the code, but with different example. So we have data frame. So again, how about we create a random number of 3 by 2 matrix? Then we denote the columns. Actually, you don't need to write the columns. You can go directly. So okay, let's see the shift tab. So here are the parameters. So you have data, index, and column. So it's okay if you remove the columns and you go directly with the values. But for this specific example, I will use the column attributes. So for example, column 1, then we have column 2, then we have index is equivalent to row 1, so row 2, then row 3. So let us execute. So Alt enter. So I think I created a mistake here. So let me check this one. So data frame random. Oh, I forgot the rand. For example, we will create a normalize random numbers. So Alt enter. Okay. So this one will be the result. This is also a data frame with random numbers. These are normalized values. So let me delete this one. So also, you can also have data selection in data frame. If you're familiar again with string indexing, Numpy indexing, series indexing. So you will be familiar also with data selection in data frame. So for example, let us display again the data frame of state. So we will use this example so that we will not create any more specific data frames. So Alt Enter. So from here, the series that corresponds to the columns of the data frame, I'm talking about the columns, can be accessed via dictionary style indexing of the column. So again, if you're interested with a column population, so you state the name of the data frame, which is state, then you use the bracket notation. So specifically, if you want population here, so you can retrieve its specific column values. As an alternate also, but I'm not recommending this one. So you can also use the dot notation, but again, I will annotate this one as alternative, but I'm not recommending this one. Not recommended. So why is it I'm not recommending this one? This looks like a method. So if you defined a method also with a specific, it will cause confusion. So I will recommend using the square bracket over the dot notation. You are not all limited to explicitly typing the name of the column. So you can also use the iLoc ILOC property. Okay, let me annotate this one. You can also use that iLoc. These are integer based. So when we say a iLoc, so remember, if you are using iLoc, these are implicit index. So when we say implicit index, so you are not defining this one. So let me display the states data frame again. So implicitly, this has a specific index. So for example, although it has names, for example, the row, implicitly, these are 0, 1, 2, 3, 4. These are 0, 1, and 2. But again, if you will define this explicitly, you can state the names of the column and the names of the rows. But for this purposes, so let me demonstrate the ILOC. So ILOC, for example. So for example, we have states.iloc. So again, if you're familiar with our column and comma notation, square bracket and comma notation, so you can access parts of a data frame. So for example, so I'm accessing California here. So because I'm saying here that you start from row 0, then end in 3. So again, this is 0, 1, 2, 3. So again, the 3 is exclusive. So you remove the 3. Then in terms of column, this is 0, 1, 2. So you're specifically saying to start from 0 here, then end with 2. So again, this is exclusive. So you are retaining this one. So from California to New York only. So that's the way you use the ILOC. If you do not want to use the names of the rows and columns. Okay, so let me erase this one. So also, you can also, before we proceed, so let's have more examples. So for example, states.iloc. So let's start from example 2. we end up in 3 in terms of row. Then we select all the columns. So for example, so Alt Enter. So you retain only the New York and the area population in code. So you start from index 2, end up with 3. That will result only with one entity. Then this, if you remember our indexing, so this signifies that you select all the column. So area, population, and code. So 2 and 3. So if you denote that, so you start with column 2, then end with 3. Again, this is exclusive. So you retain only the column 2. So understood? So I hope you're understanding this one. So next one. So we also have the LOC indexing. So you can also use, instead of the ILOC, you can also use the LOC, which is explicit. When we say explicit, as you have defined the names. So let me demonstrate. So states that LOC. So then you will use again the square bracket. So start from the beginning, then end up with New York in terms of row. Then from population, so as you can see, I'm explicitly stating the names of the column. That's the difference between ILOC and LOC. Population, start from population and select onwards. So the result of this one will be this one. So California, Texas, and New York. Okay, so let me show the states again so that this will be clear. So, and let me annotate. So you're selecting here from the beginning of the row, then end up with New York. So you're selecting from here. Then you start with the population, then select onwards. So this will be retained. So this is specific values. So as you can see, so California, Texas, New York. So California, Texas, New York with population and code. So this will be removed. So the only one we'll retain is California to New York. So that's how you use the LOC. When we say explicit, you use the name of the column or the specific row. So let's move on. So keep in mind also, before we proceed, so keep in mind also that a data frame is an enhanced two-dimensional array. Thus, we can also transpose the full data frame. So we can also use the Numpy Transpose in order to switch the rows and columns of our specific data frame. For example, np.transpose states. So this will be the result. So the rows and the columns are flipped. Also, as an alternative, you can also use the methods. So states.t denotes also a transpose. So Alt Enter. So we will have the same result. Next one. So we're going deeper and deeper. So let me just display the states again. So our original data frame so that we can compare. So you can also do conditional selection. So before we proceed, so we can also do conditional selections. Okay, so how about conditional selection? So you can also do this. For example, states, then you provide the states data frame again. So for example, area, then you use the comparison operator. So let's say less than this value. So I think this one is 1, 2, 3, 2,000, 20, 200,000, 2 million, 20 million. So let's say you're interested with states with the area of less than, for example, this specific value. So these are conditional selection. So the result of this one will be the same. So let me add another 0. So less than this specific number. So the states of the area will be less than, okay, so this one. So let me remove some zeros so that we can extract specific conditional value. Okay, so maybe this one. So the only states that remains are New York, Florida, and Illinois, because it is less than, I think this one is 200,000 in terms of the area of the states. So you can also do multiple conditional selections such as this one. So for example, states. So states, specifically we're selecting here area of less than 200,000. So we're selecting this one. And we are selecting for the specific population. Let's say less than, let's say a specific value. I think this one is, let's start with 2 million. 1, 2, 3, 4, 5, 6. So this is 2 million. So let's take a look at the data. Okay, so let's have 20 million. So if you execute this one, I think this will be an error if you're using this conditional selection. So why? I think this one will be error. So first of all, the parenthesis, this did not match for the states. So, but I think this will be an error again. So the truth value of series is ambiguous. So the error states that you use a.empty or NO. But the error here is we cannot use the AND. So remember our logical operators during our if statement. So we use AND. So for data frames, so this will not result with the correct code. So this will be an error because this is for singular values only, like true or false, true and true. So this one is a data frame. So we will use also the AND, but with a different symbol. So this one is the AND when you are using conditional selections on data frame. So if you execute this one, so we will filter out less than 200,000. And I think this one is 1, 2, 3, 4, 5, 6. This one is 20 million. So the states that remains are New York, Florida, and Illinois also. So changing this one, for example. So how about greater than, for example, 19 million. So let's see if the result will be different. So yes, so the result will be different because only New York and Florida has a population of greater than 19 million. Also, you can also do this. Also, you can also select specific columns to display. So let me copy this one. So copy. And what if you want only to select specific columns that you want to display? So let's, for example, I want to display only the code. So same result, but you're only displaying the specific code. But what if you want to display the code and the population? So what will be the correct code? So you pipe it down with 2 square brackets. Then you separate the code and population with a comma. So Alt, Enter. So this one. So as you can see, the area has been removed already. So I'm only interested in displaying the code and the population. So we have conditional statement. Then we are specifically selecting only what rows to display. Okay, so for the next topic, maybe we create some we have another alternative selections in data frame. So as another alternative, also you can do this one. So for example, you got states, then you select the area. So these are simple example. Then what if you want to select the area in the code? So states. So the same thing, you will do this one. So area, comma, and the code. So you pipe it down. If you want 3, you will result to ILOC or LOC if you want multiple. Because we're dealing here with many columns when we are analyzing data. So these are just simple sets of data frames. So also you can select by row. So for example, you can select also specifically by row, as you can see on the next sections of this code cells. So you can also create, okay, let me comment this one. You can also create new columns to an existing data frames by, so I will demonstrate it. So example, you want to add another column of density, for example. So population density. So you denote this one by assigning a specific indices. This is usually column. So density is equivalent to states. So let me select population, and we divide it by the area. So we will compute the density of the population. So this is states over area. So now let me display the new structure of states. As you can see, we have added a density column. So for this density population is 90, 38, 139, 114 based on the area. So as much as you can add, you can also drop specific column or rows. So drop columns or rows. So we will drop specifically, let's start with dropping the density as an example. States.drop. So you provide the column name. So density. So if you execute this one, this will be an error. So I'll explain why. So density not found in axis. So why? So because if you are dropping columns or row, you must specify the axis. So this axis, in terms of dropping data frame, the axis equals 1 denotes a column. So it is reversed from the previous topic, which the axis 0 is the column. So for data frame, so remember, axis 1 is column. So if you want to delete this column density, so you will provide specifically the axis one. Then, if you execute this one, so the density will be dropped. But if you display again the states data frame, so the density remains, although you have dropped this one. So one important parameter is the in place. If you provide a true value here, you will give the data frame a permanent change. So if you want in place true, so compare this one. So I will remove the in place first. I will execute this again. So Alt Enter. So density is dropped. But if you display the data frame again, so density is still there. So if you want to drop this one permanently, so you place the in place parameter and place a value of true. So this means to drop the density column permanently in place. Alt Enter. You display again the states. Alt Enter again. So this is a permanent change. So don't forget, if you truly want to remove a column, you provide the in place. Also, again, you can also drop a specific row if you want. For example, let's say we want to drop the Texas row. So states dot drop select a specific row index, then select a specific axis. So we are here dropping rows. So 0 axis 0 is row. So I want this to be drop the Texas row. So again, the result will drop the Texas. But again, if you execute again the states variable, which is a data frame, so Texas will remain. So if you want permanent change again, so you provide the in place parameter of true. So shift enter. So let's see these states. So the Texas row is permanently dropped. So don't forget the in place parameter right here. So as a summary, okay, so we have discussed data frames. This is the part 1 of our data frame series of Pandas. So you can create data frames. So from a dictionary, you can pipe a value of dictionary, convert it to series, then convert it into a data frame. So we also discuss here uh, data frame indexing, construction of a data frames object, and list to dictionaries and dictionaries to data frame. So dictionary from series objects, a two-dimensional NumPy array to a data frame. How about creating new columns and dropping rows and columns? So remember the in place parameter to make a permanent change to the state of the data frame. So use the ILOC or the LOC. Remember, ILOC are implicit. Then LOC is explicit. So these are just the first portion of our discussion about data frames. So more topics to come in the next section. So thank you very much. See you at the next lecture.